So in these two practice problems, what we need to do is to use these two equations. So when we use which equation depends on the situation, but let's look at the problem itself. Hardy-Weinberg equilibrium means that we have those 5 conditions that require that tell us that there's no evolution going on. You should know what those 5 conditions are now that we've completed the exam or the quiz. The frequency of the homozygous recessive genotype is 0.09. What does that tell you? The genotype, homozygous recessive genotype, since you're talking about homozygous and recessive, you know you're talking about 2 alleles. You know that in this case, let's go ahead and just pick a letter. Let's say it's little a, right? That frequency of that is going to be q squared. Remember, you have 2 of them, so it's going to be q squared. Q squared is equal to 0.09. Now, the question is, what's the frequency of individuals that are homozygous dominant for the homozygous dominant allele, right? What's the frequency of individuals that are homozygous for the dominant allele? So what we're looking for is big A, big A. We're looking for the frequency of big A, big A. Well, if you know q squared, then you know that you have q squared equals 0.09. You can take the square root of q squared, or square root of 0.09, which is equal to q is equal to 0.3. So q is equal to 0.3. Now that tells you q. That doesn't tell you the dominant allele. That just tells you the recessive allele frequency. How do we find the dominant allele frequency? Well, we'd say P plus Q equals 0.3. Well, I'm sorry, that's not true. We'd say P plus 0.3, because Q is 0.3, equals 1. Subtract the 2, P must equal 0.7. Now that's 0.7. That just tells you P. So if they ask you for what is the frequency for the dominant allele, you'd be done. It's 0.7. But that's not what they're asking you. They're asking you the homozygous dominant allele, right? How many individuals are homozygous dominant, right? Homozygous for this allele, the dominant allele. So they're asking you for big A, which means what? They're asking you for P squared. So you have P, just square it. Well, if you do P squared, you know that it's equal to, P equals 0.49. That's your answer. It's 0.49. There's a couple takeaways from this practice problem. First, you'll notice that we had to follow 2 steps. First, we had to follow 3 steps. First, you had to the first step was finding what was Q. This next step was to find out what P was. And the last was to find out what was the percentage of individuals that were homozygous for the allele P. The second takeaway is that they predicted wrong answers. They predicted that someone would come up with 0.7 and think that was the frequency of homozygous dominant individuals in the population, and they have that answer waiting for you. The actual answer is 0.49, but they predicted that somebody would make the mistake and see 0.7 and jump on it. So you got to be careful. The next problem gives you the percentage of RH positive. Of RH positive people in the population. But you got a problem. They give you 84% have a let's say big R blank, right? We don't know if they're big R, little r. But we do know something. We know that if 84% are dominant, recessives do I have? What is my, what's my Q squared if I know that all my big R people are 84%? The only thing left, if you think about the whole pie, if a good percentage of these, most of this pie is dominant, so it's big R blank, what's left? Only little r. So Q squared is what's left over. So if I have 84%, then what I have left is 16%. So if 84% of the population is dominant, that means 16% must be recessive. So this is 16%. Now again, this is the recessive allele, and they are predicting that you're going to go ahead and choose 0.16, because if you took 16% and changed it into a decimal, it would be 0.16. So they're betting that you're going to go ahead and choose B. But that's not the question they're asking you. They're asking you what is the frequency of the Rh positive allele. So what they want to know is what is the frequency of big R in this whole population. So if you know what Q squared, Q squared is 0.16. Let's go ahead and write that, what we know, down, Q squared. So that was all part 1. So Q squared, in part 2, you know that Q squared is equal to 0.16. Your question is, what is R? Well, what's the square? First, let's find out what the square root of Q is. Why do I want to take the square root of Q? Because I know that P plus Q equals 1. So I need to find Q by itself, not Q squared. So I can take the square root of 0.16, and that's 0.4. So Q, and I'll go ahead and put the square root sign in. Q is equal to 0.40. That's my Q. So if P plus 1 equals Q, then P plus 0.4 must equal 1. And therefore P must equal 0.6. Now, again, they predicted that somebody would choose 0.16. That was not the answer, but you'll note that the actual answer is 0.6, and that's letter D. Be careful. They're always going to try, or they tend to try to predict wrong answers. So finish your homework practice problems. Let's go over them tomorrow in class and make sure that you're ready for Friday's quiz.